If you do not have R Studio downloaded on your computers just yet, definitely start doing that right now as we are going through our introductions. Also contained in the link on the box site are a few data sets. There should be 3 of them. There's the same data set as an Excel and a CSV file. Want to make sure you download both of those. There's going to be another character data set that's a CSV file. Make sure you download that as well. So go ahead and do that stuff while we do our introductions, just for the sake of time. If you have questions or you need help, if you're getting an error or something like that, just raise your hand. I probably won't stop to address it, but Zakay will be walking around to help answer your questions, and so will Russ will be hovering around. So if you have any issues, just raise your hand. Okay, so let's go ahead and start. The link is still up there if you guys still need access to it. Introductions. I'm Jamie Samper. I'm the Associate Director of Data Computing and Research Support at Analytics at Wharton. Along with me today is Russell Walters, right here. Russ works with me at Analytics at Wharton. He's a Senior Data Analyst. So the 2 of us are just a little piece of the puzzle of the data and research team at Analytics at Wharton. Okay, the link is going to go away now, but it is on the whiteboards over here if you still need access to it. So before we get into talking about R, I just want to get a sense, like a temperature check of how everyone feels about R. This is a very introduction workshop for people who have never even seen R before. So if that is you, can I get a show of hands? Have you anyone here not use R at all? Lovely. Okay, I was worried everyone's would be no, we already know what we're doing, and I'll just have to skip forward a bunch of stuff. That is awesome. Okay, anyone feel comfortable in R and they're just here for a refresh? Okay, that's good. Good to know. All right, so getting into some introduction stuff. This is where we're going to be going in today's workshop. So I'm going to give an introduction to R general concepts that you should be aware of, and then we are going to talk about how to set up the R environment and how to navigate it so that you feel comfortable being able to see your data in different spaces and being able to work with your data. Then we're going to get into some basic R concepts, so some language that is very specific to R, some typical tasks that you do in R when you're getting all started for data analysis, and then we're going to get into the weeds with the data. So we're going to talk about how to import your data and how to manipulate your data so you can clean it and just view it in different ways. We're going to end with some exploratory data analysis, or EDA, and we're going to create some visualizations. I have a whole section at the end on creating visualizations and then also customizing them so that they look nicer, they're more interpretable. If we don't get through the customizations, they are available on the R script that is available on the Box website. So if you want to do that in your free time, you can go ahead and do so. It's a Harry Potter data set. It's really fun to go through, and I thought at least it would be easy for people to be able to follow along. So speaking of the R script, in that Box file, there is a R script. So once you have R Studio downloaded, you want to import that R script so that it will populate in your R Studio app, and then we will be able to follow along from there. Okay. So, some introductions. Kind of went over this before, but this workshop is intended for people who have minimal to no experience working with R. You do not have to have a technical background at all to understand the concepts that we're going to be going over today. And it's for people who are just interested in becoming familiar with the world of analytics. I think it's a really nice stepping stone to get your feet wet with data. So after this workshop, you should expect to feel more comfortable navigating R Studio, understanding how it works, importing data, summarizing your data, creating basic visualizations, and then saving your data and sharing your data, because that's going to be a big perk of using R, is the ability to share your data. Okay, so getting started. What is R? So R is a statistical programming language for data analysis and for creating visualizations. When we talk about R, we're basically saying it is a language. So you might have heard of other different types of programming languages. A really common one is Python. They also have SQL or SQL, HTML, JavaScript. These are all different programming languages. And you can think of them as a comparison to a foreign language. They all have syntax that makes it work together, but that syntax is not going to translate to other languages. So if I just took my script in R, I wrote a bunch of code in R, and then I imported it into a notebook using Python programming language, it's not going to read it. It's going to say, I have no idea what you're telling me to do. That's not how I operate. But the good thing about programming languages, kind of similarly to foreign languages and spoken languages, is that once you learn one, all the others become easier to learn after that. So why should you choose R compared to other programming languages? So one of my colleagues over here, Jaden, is like an expert in Python, and we just do not speak the same language because I'm an R girl, he's a Python guy, and there's strengths to both of them. And so we go back and forth all the time about like which one we should be using. So if you do a lot of creating applications, you're trying to design apps, anything that's a little bit more advanced with programming and coding, Python's a really great tool. My background is in research, and so I just do statistics, data analysis. And for that purpose, R is awesome. If you just want to run analyses and create visualizations, R is a really great resource because it's very straightforward. It has a very direct purpose to it, and I think it's user-friendly, especially when you start getting into R Studio. It's also really flexible. So the visualizations that you can create and customize are awesome in R. It's a really powerful tool for creating visualizations. R is also open source. So what does that mean? One, it's free, which you guys are all experiencing right now. You can just download it and you have it. Penn doesn't have a license or anything. Anyone can just download R. The code that you can create in R is open source, and a lot of that code is contained within packages, which we're going to get into in a second, and I'll explain what a package is. But I can create a script in R like I did for this workshop and share it to you all, and you all, as long as I provide the data sets, which I did, you can create exactly what I'm going to do today, which is really awesome. There's also an extensive support community in the R world, which is awesome. There are a few websites that if you're interested in knowing about them, I can go into them at the end if anyone has questions. But if you have a piece of script that is just not working, like a piece of code that you wrote, you can upload it to one of these websites and be like, can someone please help me either make this more concise or tell me why it's not running? And you'll get an answer within like 2 minutes. There are people that are just like obsessed with the support world in R, and it's really, really cool. I've learned about so many cool packages and tools to create visualizations by talking to strangers on the internet in the R forums, and it's really awesome. Okay, so what can you do in R? Talked about statistics, data analysis, what is contained within that. So you can explore data, you can manipulate data, analyze it. You can create models, both basic models and sophisticated machine learning models, which is going to be the next part of this workshop that's happening in a few weeks from now, in 4 weeks from now. It's going to be more advanced modeling. You can also create visualizations, so where you can run an analysis and then visualize the output of that analysis. And like I said before, you can share your code with others. So I alluded to packages before. So packages are extensions to the R statistical programming language. So they contain code and kind of rules about the way that you can run an analysis. So let's say that you want to create a really cool visualization. Well, there is someone who created a package that wrote code out that when you use that code, it's more concise and it will be able to understand what you want to do to create a visualization. So you don't have to program every nitty gritty. So you don't have to tell it, I want an X and Y axis. If you're saying I'm doing a bar chart, it's going to put that there for you. So they just make it easier to do all the things that you want to do. So people all over the world write these packages and you can install them into your own R space. Then you can read them into your space saying, I want to use this package right now. And then you can use the little shortcuts that they have created. R packages are not just made by like the inventors of R. Anyone can make a package. So it's a really common task for PhD students in statistics. That's usually their capstone, is like create a really sophisticated, cool R package. And then literally anyone can use it. It's pretty cool. So there is a collection of packages that you're probably going to hear about the more you start working with R. For those of you who have already used R, you might have heard of it already. It's called the tidyverse. So the tidyverse contains all the packages that you see here, and they do different things. So if you ever hear of these packages, just know that if you know the tidyverse, these are all contained within it. So there's dplyr for data manipulation, which we'll go into what that means later on. ggplot2, which is for visualizations. It's by far the most popular package to create visualizations. And then we have some others that we're not really going to get into, but for today we'll get into tidyr, which is for data cleaning. And then all these others. But you might see these as you're learning about R. You might see these names of packages. So I've never seen a source that just like puts them all together. Like this is what all the packages do. So these slides will be accessible after the workshop. So if you ever need to reference back to them, they're all here. Okay, so before we get into R Studio and then actually using it and diving through data, there are some concepts and terms that I just want everyone to be familiar with. So you're going to hear them quite often. The first is a data frame. A data frame is just a house where you keep your data. You can make as many data frames as you want to, but when you reference that data frame, you'll only be able to access the data within that data frame. That might seem a little bit circular, but it'll make more sense once we actually get into RStudio. Data frames can be thought of as a table, but they're not a table. It's like a data set that you can just load into it, and you can create a table from it. You'll also hear the word tibble, which is just another way of working with tables. Tables are different than tibbles, are different than data frames, but they're all kind of similar in the concepts. We'll be creating data frames quite a bit in today's section, so just be aware when you hear that word data frame, that's what I'm referring to, because it will never say data frame, but I'll try to point it out when it does come up. For creating variables, you can create as many variables as you would like to. You can create, when you create a data frame, you're technically creating a new space, which might be considered as a variable. When you're creating anything new, you have to assign values to it. And so you'll hear me say the assignment operator. The assignment operator is a less than sign and a dash. So from your perspective, it looks like this. Assignment operator. So anything, I'm like naming it, assignment operator, I'm telling it what's going to go into it. So if you hear me say assigning, variables, this is where all those terms are going to come into. When you are naming variables, R is very sensitive to a lot of things. It's case sensitive. It's, I don't know how to say, quotation sensitive. If you use curly quotes compared to straight quotes, or if you use single quotes compared to double quotes, it won't like it. So you have to make sure that you're using the right things. You're not expected to know how to do that. To this day, I always have to Google. Like when I'm writing, if I'm trying to create this type of visualization, which quotes do I have to use? And so if you're naming variables, I would name them how you naturally type. So if you use underscores a lot, use underscores. I wouldn't use spaces. You can, but spaces get a little bit tricky of when they're accepted and when they're not accepted. If you tend to capitalize things in the beginning, go ahead and do that, but make sure that every time you refer to that variable or that data frame, it has to be capitalized as well. There are also different data types. So we will be able to see this when we get into RStudio, but just to give everyone an understanding beforehand so you know what we're talking about when we get there. A data type refers to an individual variable. So something like speed. The speed is the variable, and then the data type for speed is going to be continuous, because it can range from, it can't be a negative value, but sometimes they can be negative values, and they go up to infinity in theory. There are categorical variables or factor variables. So a factor variable is something like your year in school, freshman, sophomore, junior, senior. You fit into one of those categories. And they can be factor or they can be a character because they can be written out. If I write freshman, R is going to be like, that's a word, that's a character. But we know it's a factor, it's a categorical. And so you have to tell R that this is a categorical variable. Again, we'll get into that later on. But just so you're aware of the different types of variables you'll see. So numeric and integer are both continuous, and then things like character can be factor, categorical are factor, and then interval variables also are factor variables. Okay, so now we're going to get into the differences between R and RStudio, and then get you familiar with the RStudio setup. As of right now, are there any kind of foundational questions? Has everyone downloaded R and RStudio? Yeah? Okay, awesome. I'm going to turn it over to Russ.
Great, thank you. So we're switching from R, the coding language, to RStudio, the software. There's lots of coding languages, like there's lots of languages. Coding language R is like English. You can write English lots of places in a Moleskine notebook, in Microsoft Word, in Google Sheets. We're going to talk about RStudio. RStudio is an integrated development environment. That means like the place you write code and other stuff around that. So RStudio is also Google Colab, which is useful. There's a handful of other places you can work and code in R. So I'm going to give you a tour through this software. This is hopefully what you're seeing, something like this. This is when you first open R, or RStudio rather, and then you can get these different panes. I'll talk. This is sort of the Carly, what you're seeing now, the blank space. Jamie will start back here. I'm going to show you what it'll look like as you start doing things. Down here is the console. You can use R as a calculator over here. So in your console on the left bottom hand side, type in like 1 + 1 or something. Do a little simple math. Can you try 1 + A? What do you get when you do 1 + A?
Put it into your applications.
Anybody?
Ever?
Yeah. Okay. Now do the assignment operator. Do A assign 1 to A.
It's there.
So now you're gonna make A a 1. Now do 1 + A. You got 2? All right, and then one final trick question. Do 1 plus true, and then tell me what you get. So true is illogical. True is coded as 1, so probably you got 2 when you did 1 plus true. Yes. Is that true? Okay, so now I'm going to show you a full RStudio. This is a lot of stuff. We'll be building towards this. We're going to start back at blank and then build towards this as we code together. But we want to show you sort of what it looks like full as well. So we played around the console here. You can play around again with a little more sort of RS calculator down here, directly entering code in the console. This is where it's the code editor. This is where you can write code. So before you run it, you can write code in here, and then the green parts are comments. The hash, these are comments describing what the code's going to do. When we switch to our coding script, there'll be comments that are describing what the code does. So there's a bunch of code here. You can run it either by hitting the run button here or highlighting chunks and hitting enter. We'll talk about that further. So this is where you can write code and save code and comment on code. This is where you see what was run. So like this plotting thing here, which is up here, got run down here. This is where error codes get generated as well. We'll talk about error codes in a second. And then over here is the environment. These are the things that are open, like the files that you have open, or the data frames, rather, that are open. And then plotting down here with lots of different tabs. Plot and file are some of the most commonly used. You can get help, but you can also get help from lots of places like Google, Stack Overflow. This shows you packages. So we'll mostly be using this to look at plots. So the code that we wrote here gets run on the console, and then you can visualize what you coded up over there. So this is sort of the full thing complete. We're going to build towards that as we do our next piece, running through some code.
Awesome. So let's get into the fun stuff, RStudio. Okay, so how I kind of structured this R script is how I approach it when I'm going to analyze some data. So the first thing that I think everyone should do is to check what your working directory is. Your working directory is the file on your computer where R is going to pull everything from, and it's also where R is going to send everything. So if you create a visualization and you're like, I'm going to save it, it's going to save it in your working directory. It's also going, if you save your script, it will save it in the working directory. So that means you have to know your working directory, because if you're going to import data, you have to know where it's coming from so you can store it in the right place. And this is the one thing that really trips students up in the beginning. So can everyone see this script? I can make it a little bit bigger if needed, but can everyone see it from where you are on any of the screens? Okay, awesome. So the code to see your working directory is get wd parentheses. So I have all this written out for you guys already. You don't have to type it out. But if you would like to just follow along, and you can do it on your own after, you can totally do that. So as Russ explained, the top is the script. That's where we are writing our script out. And then the bottom, the console, is where you'll see the output. So what's great about RStudio is that the script and the console are separated, so you can keep all your work in one place and the outputs in another place. I'll make the console a bit bigger so you can see it. So R is telling me that my working directory is my documents folder, and then I have a folder for everything about this workshop called Intro to R. So great, that's exactly where I would need it to be. Let's say, for example, I wanted to change it to downloads, because that's what you all probably are going to be doing. So if you set it to just your downloads area, anything that goes to your downloads, you'll be able to pull from. So the code to change your files is the set working directory, and then I have a Mac. So the file extension is just based on Macs. I know PCs, I think the backslashes are forward slashes or something like that. But you want to find your own navigation route. So if you go to your files, you can usually see what your path is. You want to copy and paste it into R and say, this is my working directory. And then you will run that line. What's the other thing? Has to be in quotes, in double quotes, the path name. So right after the parenthesis for set working directory, double quotes, put your file path there. For running lines of code, I use a Mac, so I'm very comfortable with like the keys on Mac. I'm not sure what it is on a PC, but for Mac, it's Command Enter is the shortcut to run. So you want to make sure at the very end of your line, Command Enter, it runs that line. So if I want to set my working directory, Press that at the bottom. If I don't get any errors, everything's good. R will always tell you if something's wrong. It won't tell you if something's right unless you ask to view the thing that you created. So I want everything to be back into my intro to R, so I will reset it there. But after I set this to my downloads instead, I can then go back up to my get working directory, and now downloads. So sanity checks I think are really important in R. I always do them. If you look at my own like R scripts, I have the same command at the beginning and end of like everything. So I just want to make sure that what I did is correct. And it's a little reminder, sanity check, because I don't want to keep going and then everything gets broken. Okay, so we'll back to set my working directory to intro to R and confirmed that it is there. Okay. Also, I meant that today's would run. If you do not use the shortcuts, whatever, you can press run here to run. So if I just put my cursor at the end of a line of code and press run, it'll do it. When we get more sophisticated with our coding, there'll be like several lines. You can always highlight whatever you want to run and then press run, because when you press the run command here, it'll run everything beforehand. And so if you want to be very selective, just press, or you can highlight what you want to run. Also, within R and RStudio, you'll see a lot of these green lines that start with the pound sign or a hashtag. Those are comments. So this is basically anytime you see the hashtag in green text, I'm talking to you. That is my voice saying what we're doing at this time. So if I run this entire, if I highlighted this and I ran it, R would completely ignore everything that follows the hashtag, and it would just run the set working directory downloads. But you would see the console, my little note to myself there. Any questions about running things, setting working directory? Yeah?
Can you just describe again what we're doing here with the working directory downloads and then intro to R? Like, what is the purpose of it?
Yeah, so the downloads, documents, intro to R is all from my computer. So wherever you want to store the data, so I gave the downloads assuming that you guys would download the data and it would live in your downloads folder. Wherever you put that information is where you want to put in here. So like my username for my computer is Samper. So this is where my files live. So the working directory is just the place where R will pull files from, and it's where it'll put your files. So you need to tell R where you want to do that. Another thing you could do that's a little bit more user-friendly is you can go to session, and then, not session. Session, set working directory, and then you can choose the directory. So mine is set to my documents, so it'll show up in my documents, in my intro to R folder, and you can set it that way if that's easier. So 2 different ways to do it. Does everyone feel good with working directories? Okay, cool. So next is installing packages. So I already talked about the tidyverse. So now we're actually going to get into installing it. So this code right here, install.packages, is how you're going to install everything that you need to use for R. For when you are installing the package, the name of the package has to be in double quotes, how it is here. So when I go to run this, I already have this installed, so it's not going to do anything super crazy. It's not going to take too long. But when I run this line, I want everyone to look really, really quickly. You will see, so I already have it, so it's telling me it's going to update it. There will be a pause button here as to restart the R session. But when it's downloading, so when you guys will see, is a stop sign there. The stop sign is basically just saying that we are doing something here. Like R is working, so it's not going to do anything else. If you ask R to do a very high consumption type of task, so installing the tidyverse does take quite a bit of time, it's a lot of packages, it will not run anything else after that. And so I've gotten into that mindset where I run something and then I'm running another thing to like sanity check. I'm like, why isn't it coming? Why is it frozen? Because I'm not looking at the little stop sign saying, hi, I'm working. I'm not going to show you anything else at this time. Okay, hopefully it doesn't need to actually restart. Okay, great. So after you install packages, you have to load them into that working session if you want to use them in that session. Once you really only need to install packages one time, but every time you update R, it sometimes will wipe out your packages, so you might need to install them again. But because I have the tidyverse installed, I just want to read it into my session. So this code right here, library, is saying, hey, I want to do some data manipulation and cleaning and maybe make some visualizations. Bring the tidyverse into my workspace so I can use it. And then I run it, doesn't say anything. It just says, yep, it's right there. Again, R doesn't tell you when you do something good. It only tells you when you do something bad. If you don't know if you have a package installed and you don't feel like wasting your time installing it and letting R do its thing, you can go to the Packages tab here in your little environment, and you can scroll through and see all the different packages that you already have installed. If you see it here, you just have to read it in using this library function right there. Okay, next thing is another thing that trips students up quite a bit. If you open a parenthesis, you have to close a parenthesis. What's really great about RStudio is that if you just type in an open parenthesis, it already closes it for you. It's like, please don't forget about it. Just start typing anything you want, and it's already in a closed parenthesis. If you're using the R app, it does not do that. So it's little bit less error detection abilities. So if you do not, so this is just, don't even worry about this code right here, just for example purposes. If I don't close this parenthesis, R is basically saying, one, there's a red arrow or a red X being like, this is not complete. You have to do something to fix it. If I tried running this, R is not telling me that I have an error, but it thinks I'm not done. And you know that because there's a plus sign down here. If R is ready to roll, you will see a greater than sign there. If you see a plus sign, you didn't finish something that you were just working on. And so if I close this parenthesis, I'm going to get an error because I didn't read in this data, but at least I have the greater than sign there, so you know that you're ready to go. So there are a few things to look out for when you're reading your data. Okay, so now we're actually going to read data files into our space. I'll just make this a little bit longer so everyone can see it. Okay, so we're actually not going to be using these data sets, but I wanted to show an example of when you have a CSV file and an Excel file, how to get them into R if you don't feel like changing them on your own outside of the R workspace. So this first word right here, univs, I created that. That's from my brain. I'm saying this is a university data set, but I'm lazy and I don't want to type university data set, so I called it univs. In my brain, that's what makes sense. You can use whatever you want. This is what I'm creating, and R knows I'm creating this because of the assignment operator that we went over before. So R is saying, this is new, and the value of that is going to be everything that comes after it. So one of the functions that already exists in R is to read CSV files. And so R knows this language right here, read_CSV. And then you just put in the name of your file. And so this is one of the files that you guys had to download. As long as this file, this CSV file, is in your working directory, you should have absolutely no problem running that, because it's exactly where you told R it would be. So now something else just happened. If you look at our global environment, we see our data set there. So that's another sanity check. It's there. And you can see some things about it. So there are 910 rows in this data set. There are 9 columns. And you can expand it, and you can see the individual variable. So every variable name followed by that precedes a $sign is a new variable in the data set. Something else you can see is the type of variable it is. So if it's num, it's a number. If it's a CHR, it's a character. And we'll go into this in a little bit more detail later on. But you can see that your data is there. Another way that you can see it in a little bit more detail is to view. So you can use the view command. Univs, that's what I created. I'm saying that is my data frame that I want to view. And then it'll open a little tab next to your script, and it shows you the data. And so those variables that we see here in the environment, the 910 rows of the 9 columns, you see it right here. Those are the 9 columns that we have.
Wow.
So I'll pause in a second, but that's reading in a CSV file. If you want to read in an Excel file, that doesn't exist in base R. Base R apparently is like, no, we don't believe in Excel, we don't do that. So you have to install a package to load in Excel files. That package is called readxl. So just like we did with the tidyverse, install it with the double quotes, read it into your space. You do not need double quotes now because R already knows that it exists. It already exists in the R world. You just load in the readxl package, and then you can run the code here. So I did uni_excel to know that it's a different data set now. This one's coming from Excel, just so we can see that it's different. Uni_excel, it's up there. So I imported that from Excel, and then when we view that one, it's going to look exactly the same as the other. It's just different ways to import your data. I saw a lot of hands go up. What's tripping people up for this data import?
Mine says could not find function read CSV.
It could not find the read CSV function. Did you install and load the tidyverse package?
Oh, I haven't.
There you go. Yeah.
Same problem, but I haven't installed the tidyverse package.
Did you get any errors when you were installing the tidyverse package?
Which I don't know.
Okay. Jingming, could you go over and see if the loading packages, if there's an issue over there? Yeah.
The issue for me is that I set a location to receive data and documents from RStudio, but when I try to install tidyverse, I'm getting constant trying URL, content type downloaded, and it's just going over and over.
Okay, I was sure.
It's never stopping. It just keeps running over and over.
I thought that meant it was down.
Yeah.
Yeah.
So the tidyverse is a lot of packages. So that's why I brought up the notice about the red stop sign. If you see the red stop sign, it's doing something.
Yeah.
The tidyverse is huge, so it will take quite a bit of time the very first time you install it. After that, it takes no time to read it in.
Okay.
Yeah.
Oh, that's annoying.
Okay. Other people feel good so far? Reading in data? Back there?
How do I get rid of other data that might be there in my environment?
Great question. So if you previously load in data that you don't want to work with in this session, the broom up here will remove it. So I'm actually, like I said, we're not going to use the university data set, so I will clear it. Once you clear it, it's gone, unless you load it back in. So if you're working in a data set that you've been spending a lot of time in, never do this because it'll just ruin your entire life. I'm not going to use these again. So I feel very confident in clearing that space. Now they're gone. But if I reference back to that, R is like, nope, you got rid of it. I don't know what you're talking about. So you have to read it in again.
Also, one more question. I'm getting an error on Mac saying expected comma after expression. What does that mean?
So there's a comma missing in one of which line of code did you get that from?
The assignment for Jan 1, the univs, and the view function, all of them I'm getting the same error.
You have to close the bracket. For
The
Jan.
bracket is closed.
Yeah, make a folder which means
That's an error in the line anyways.
What was that?
So that was, you were explaining the error, right? How you can see the error in the Jan 1, right?
This one, the January 1? Yeah, so I deleted it so you would see an error. You got to put it back. Yep, okay, cool. So data is in. So now we're going to upload a data set that we're actually going to use. So in this case, you do not need to download this data set. It already exists in the R environment. People who created the tidyverse package gave you this data set to practice your RStudio skills. So we're going to install a package that literally just contains data. So that package is NYC Flights 13. It contains all the flights that departed out of any New York City area airport, so LaGuardia, JFK, and Newark in the year of 2013. Once it is downloaded, you just read it in. And again, R doesn't tell you anything. It just says, okay, thanks. So how this data set is contained in the package is in a tibble. I mentioned tibbles before. Tibbles are kind of like tables. They're a little bit more user-friendly, and they store the data in a different type of way. But if you want to see your data and view your data, you're going to want to make that tibble into a data frame. And so I'm going to make a data frame called flights DF. That's the data frame of flights. In my brain, that's what makes sense. You could call it whatever you want. Flights already exists as the tibble. But as we just saw, I loaded in this package, and I don't see flights anywhere. Where is this tibble? I don't see it. I want to see it, so I'm going to make it a data frame. But it's called flights. That you have to know already. That's not intuitive whatsoever. So I create a data frame, and now it's there. So now I can see this flight's data. I can see the different types of data that are in it. And then if I wanted to view it, I just use the view, and then I would do flights DF. So, yes, question.
What specifically makes flights a data frame? Is it just assigning it to any variable name?
Oh, yeah. So when you are creating a name and then do an assignment operator, it's a variable. But R will be able to look at it and be like, this is a data frame. I can make, if I wanted to make a variable, I would kind of do the same thing. I would create a name, do an assignment operator, but then I would tell R, from this data set, this data frame, pick this variable, mutate it in any way, and that's what we're going to call it. So you tell R. If you're just telling R, it's just this data, it's just data, it's going to be like, all right, it's a data frame. So you basically tell it whatever it is that you're creating, what it's going to be, what the structure of it will be.
There the question that also is flights you mentioned was a tibble, right?
Yeah.
So why isn't flights DF also a tibble since we're just assigning it?
Yeah, it's because a tibble is just data. It's it's structured in the sense that it's a table, but it is just data in general. So it's just going to make it a place that we can see it. It's essentially not really changing its structure. It's just allowing us to see it and be able to reference it. Okay. So now let's look at the data type. So I mentioned this before. We have categorical, we have continuous. How do I know what my data is saved at? Actually, let's start off with why do I want to know how my data is saved? It's very important to know what type of data types you're working with. If you are trying to do something like make a bar chart, it's going to be, and you want categories at the bottom. If you don't tell R that those are categories, it's not going to treat them as categories. It's going to just say, I can't do it. It's kind of like a toddler that throws a tantrum. It's like, nope, I don't know how to do that. I'm not going to do it. Like I said before, when we're doing something like freshman, sophomore, junior, senior, if that's how your data looks like in a spreadsheet, R is going to be like, these are characters, but we know that they're factors. You have to tell R they're factors. So when we see something here, so a character is the carrier. So it's like United Airlines, United Airlines. We could make that a factor if we wanted it to be a factor variable. Right now it exists as a character. I mentioned before there are integers, numbers that are pretty much the same thing. There's also ordinal variables, which we'll get into later. An ordinal variable is categorical, but it has a nature to it. So think of things like poor, fair, good, excellent. Those have an inherent ordering to them, but they're categorical. So we call those ordinal type of variables. So you can see the different types here. First step when you load in your data, you always want to see how it's structured. You can tell R how to change them. So we'll do this later on as well, because there's a point where there's a character variable that I need to be a factor, and you can tell R, make this a factor variable. You tell R what the levels are, and it will compute that for you. All right, so let's move this over. So now we're going to get into some data cleaning. So we're going to be using the tidyr package, which doesn't really have anything, doesn't really mean anything to you guys. It's just so you're aware of where these functions are coming from. They're coming from tidyr. So really good first step. If you are new to the world of analytics and you're like, what do? I read this data in, how do I navigate it? I looked at the data types, now what? Good starting point is to see, do you have missing values? Because missing values could totally skew your data, and then everything that you produce afterwards doesn't mean anything. So a good code that I like to use is the sum function. So you can ask R for a specific column. So let's say in this flights data frame, we have year and we have month. So I could ask R, hey, in the month category from this flights data frame, are there any missing values? But when you're starting off, a really good thing to do is just to see if there are any missing values in anywhere in the data set. And so by using the sum function, it's saying sum up all the missing values. The missing values is NA. So basically this line is saying if a value is not available, so it's missing, sum it up for everything in these parentheses, the flights data frame. So in English, it sounds kind of like really weird, but once you know R, it's kind of like how in Spanish the adjectives come after nouns. Like you'll start learning things like that when you're working with R. So this code is saying sum up all the non-available values within this data set. Wow, 46,595. A lot of missing values. If we didn't do this, if we didn't either were aware of them or we didn't remove them and we just did all our analyses, they would kind of be meaningless. So what do we do now that we know that we have missing values? So for this purpose, I'm going to say I don't even care about a single flight that doesn't have all of the information present. I want as complete of a data set as possible without going through each individual variable and saying, hey, remove missing values from year, remove them from month, remove them from day. I could tell R, create a new data frame that only has complete rows for all of or complete columns for all of the rows. That code is the complete cases right here. So this line, I'm telling R, create a new data frame called flights complete. I'm going to assign a value to it, and that is from this data set, flights data frame that I created, this is the command, complete cases, Oh, and I actually updated this. So the complete cases from the flights data frame. I'll run it. It says, okay. But again, how do we know that it actually did something? Well, we can sum up the non-available values, the missing values, from this new thing that we created, flights complete. 0. Sanity check. It worked. So it's another example of R is not going to tell you if you did it right, but you have to ask it, did I do it right? And then it says, good job, you did it.
Is complete cases I can't think of the right word, but it's a function that's already in there?
It's a function, yeah, from the tidyr package. So if you, instead of installing the tidyverse, if you just installed like deplyr, ggplot2, you didn't install tidyr, when you run that code, it would be like, I have no idea what you're talking about, because that command doesn't exist in those packages.
Do you have the trailing comma because it's a default parameter, or?
So complete cases, there are other arguments you can put in that you would put here. The space before the bracket is telling R, none of that. I don't care. Just complete cases. So I could do complete cases from only certain variables, or I could do complete cases for variables that start with a 1 or start with a 2. I can make more specifications by leaving that space. I'm telling R, don't worry about it. Include everything. Yeah.
How do you specify, like, perhaps there's only, like, you like to think about, like, perhaps there's only one column that you wanted to, like, exclude? Maybe, like, the year, for example. Like,
yep.
If it doesn't have the year, I want to take it out.
So there is a command, na.rm, remove non-available values, so remove missing values. So I would do flights, I don't know, day, if I wanted to remove everything just from the day. Flights day, assignment operator, na.rm, and then I would tell what data frame, flights df, and then I would do a $sign saying this variable, the day variable, and it would remove all the missing values from that variable.
So then the best use case for this is if you're just looking to, like, essentially eliminate a bunch of empty cells.
Yep, if you want, using complete cases, if you're like, I don't want missing values from anything, I want as complete a data set as possible. So it's like a quick fix, you don't have to do it for all the individual columns. Okay, so now we're going to get into data manipulation. So if you are from a non-analytics background, you're like, what is data manipulation? What does that mean? Data manipulation refers to tasks such as filtering your data, arranging it, selecting some data for further analysis, and mutating your data so that it looks a little bit different or creating different variables. For the sake of time, I'm not going to go over all of these, but I will show you filtering, because filtering is quite useful. So we viewed the data set before for flights. We're not going to look at it again. But this is the code that we ran earlier that I was using as an example for an error. Now we're actually going to use it in practice. So for this task, I want to only look at flights that departed on January 1st. So I'm telling R, from the flights data frame, only show me flights that departed on the first day of the month, which is month equals 1, and the first day of that month. So equals 1. If I run that code, it says, okay, did it, created that. And then I have to actually ask R to show it to me. So if you want to ever see a variable, you just type the variable and run it. You don't have to put any code in around it. And if you scroll up, you can see the day and the month. It's all ones here. R is telling you there are 832 more rows available. So if you want to look at it, you have to ask R to see all of those. Or I could view Jan 1.
This is the question out there, student.
And then I can scroll as much as I want. And I see everything that departed on January 1st. You can also filter by multiple arguments. So let's say I want to look at all flights that departed in November and December. This straight line here is basically saying and all of these. So I'm going to create a new data frame. That's November, December. I'm going to tell our filter from this existing data frame, but I only want to see 11 and 12 values that exist within that month column. And when I do that, it will create it. And then if I don't feel like viewing it, I can just go over here, look at November, December, And you can scroll and see all the information is still there just for November, December. Something that once you get more comfortable working with R, you'll notice that there are like a million different ways to write the same command, which is why our support groups are so great. Because there is, if you have like a visualization, if you have a really long piece of code and you're like, it works, but it's so cluttered, there's so much pieces of code here, and you upload it online, someone's like, oh, I know how to do it with less lines. And so this is just another way of doing the same task of filtering for November and December. You can tell R that you want to filter from the flight's data frame, the month, and then this percent in percent basically just means and. And what you're telling this command here is that you want to select every value in which X is one of the values of Y. And so the C is concatenate. So 11 and 12, if it exists within the month column, add it to this data frame. And so if I do that, it still does the same exact thing that we did before. And I could see it if I ask R to see it. Okay, so that's arranging. Questions about arranging?
Like why it's showing it's a table, we are not we are working with the data frame, right?
Mm-hmm.
Then why it's creating a table, like a filter will create a table directly?
Down here.
Yeah.
So it's creating a tibble so you can see it in your console.
Okay.
Yeah.
What's the benefit of using either one of the ways of writing the function?
Really good question. It's completely personal preference. For me, this second line, it doesn't make sense in my brain. I don't know why. It just doesn't. So I always use this if I'm trying to arrange. But there are people that the way that they learned R or just the resources that they look at when they were learning R, they framed it in a different way, and that's just what they're comfortable using. Sometimes, especially when you're doing visualizations, instead of doing this symbol to mean and, you can do a plus sign. Sometimes I like using the plus sign, so I'll look for code that uses that instead of this operator here. It's all personal preference. Okay, so I am going to skip through. I comment all of this out. So in your own time, if you want to go through and play with these other data manipulation functions, feel free to do so. I tell you right beforehand what each of the pieces of code is doing. This one is going to be important, so we'll go over this. This is mutation. So this is where we can create new variables from existing variables. So you can see here, now we have multiple lines of code. Now it's getting a little bit crazy. So I'm going to create a second data set, and I'm going to tell R, select this information. So everything after this is like telling R what to pick. And I'm making this data frame, flights 2, select from this data frame, flights data frame, and then after the comma, I'm telling it what to pick. This colon means everything in between. So this line is saying everything between year and day, keep that. I also want any variable that ends with the word delay. So there's arrival delay and departure delay. If we look at the data set, which I don't have it here, I'll just view it really quick so you guys can see that. It's not popping up, that's annoying. Here you can see departure delay and arrival delay. There we go. Just a little delayed. That was putty. So anything that ends with delay, so if I don't want to write out arrival delay, departure delay, I can tell R, any of the variables that end in delay, put them in here. I also want distance. I also want airtime. And then I have to close that parenthesis or else R won't know that that's one command. So I can create this new data frame here with just these selected variables. And then when I view it, I will be able to confirm that all the variables that I wanted are there. It's everything from year to day, which is only 3, and then delay, distance, and airtime. Yeah?
Did it have to be written like line by line? Could you have just...
That's a good question. So no, it doesn't. I love doing that. I just think it makes more sense. And there are some commands that need to be on different lines, so it's a good habit of putting everything on a different line, I think.
Every topic that you're gonna see?
Yeah, so every argument for a function, when you're creating a visualization, which we'll see later on, some things have to be on different lines. So you create a visualization, you're saying, hey, make me a bar chart, but I want the color scheme to be this, and I want the labels to say this. those have to be on individual lines. And so it's just a good habit of every time you're adding a different argument to a function to put it on a line. But I'm pretty sure with this one, if we left it all on one line, it would still run. You can test that out in your free time, but it should run.
Oh, you fixed it. Okay.
So if you use the colon to pick everything between year and day, which like makes sense just thinking about like dates as data, but could you use that to join like any columns that are unrelated in your data set?
Unrelated as in not right next to each other?
Well, right next to each other, but not related. Like color, temperature.
Oh, yeah.
Yeah.
Mm-hmm.
And so you just need to know how your data is structured.
Oh. Exactly. That's why viewing it, I think, is so important. Yep. Okay. So getting now more into mutations. So we have this more condensed data set. Just going to quickly go over how to create different or new variables. So now I'm using the mutate function. So I'm telling R, stay in the same data frame that we're working in, which is flights 2. So I specify flights 2 data frame is where we're working in. I want to mutate some things. I want to create this variable called gain. And so I'm separating it with a column now, or a comma. Now it knows it's a new argument. I'm creating a variable called gain. Gain is going to be the arrival delay minus the departure delay. I use a comma to say, that's my argument, I'm done. Next line, I want to create a variable called speed. It's going to be distance divided by airtime times 60. And then I close out the parenthesis to say, okay, that's all I want to do. We run that, and now you can see, you don't even have to ask R to see it because it's a mutate command. It'll say, hey, I just did it. And so you see down here, gain and speed. And so now you can use those variables. You can like use gain and speed in an analysis. You can use it in a correlation, in a t-test. It actually exists as a real variable, and you just added it to that data frame. You could add it as its own data frame if you wanted to, but since we set it to mutate it, it's just going to keep it where it originally came from. There's another mutation I have here, but for time's sake, we're going to skip through it. Okay. There are some EDA that I'll go through really quickly. This is also something you can do on your own time. Question?
So is the mutate going to do it in place, or is it going to create a new object?
So if you don't specify the new object, it'll do it where it currently exists.
Do you know why the flights 2 still has 7 variables? Because it's there in the data?
Why? Flights 2, because that's the condensed data set that I created. So I did create that up here. I'm saying flights 2 only contain this information, but when I mutated it, I didn't say create a new thing. I said create it within the flights 2 data frame, and so it did.
Why weren't those columns added to flights 2?
Oh, you're saying it didn't go back up here. That's a good question, because it exists as a tibble right now.
Okay.
If we wanted to make it as a data frame, I could assign it here. Yep. I could say new mutated data frame, assignment operator, and then everything after it, and it would create a new one for me. That's why it didn't populate. It just like showed up here at the bottom. Okay, so EDA. What is EDA? It's anything that helps you understand your data better. It's completely up to you as the data analyst what you want to do and what you want to see with your data. So we are going to use a different data set for this called Diamonds, which already exists in our app. So you don't need to install a package or anything. You just load in data called Diamonds. And then we're going to view it just to see what type of data we're working with here. So these diamonds have information about the carat size, the cuts, the color, clarity, depth, table, price, and a few other nondescript variables. So I said before, a really good thing to start off with is checking you have missing values. So let's go do that because we do not want to be hypocritical. 0, awesome. Okay, that makes our lives so much easier. So one thing that you might want to know is how many diamonds do you have for each cut? And cut is going to be an ordinal variable, which we talked about before. So if we look over here, the representations for cut, oh, you can't see it there. For cuts are ideal, premium, good, very good, fair. So those are on a scale, the way that they are coded as of right now. So they're categorical. We want to see how many diamonds do we have for each cut. I'm going to say using the diamonds data set, and I'm adding a command. I want to see the count of cut. Because cut is already an ordinal variable, which we can see right here, it's ordinal with 5 levels, we don't have to do anything else. If R saved cut as a character variable, because they are words, it wouldn't run this. We would have to then tell R, hey, treat this variable as an ordinal or as a factor variable, and then we would be able to see it. So this is some EDA. Now we know how many diamonds do we have for each cut category. If you want to know the range, so the minimum and maximum values for a continuous variable, something like caret size, you can use the range command. We haven't gone over this yet. When you use a $, you're specifying a variable from a data frame. So in this case, you're saying to R, I want the range, look in the diamonds data set and get me the caret variable. So before this, we were kind of doing things on a data frame wide scope. You can do things on a variable scope. You just have to tell R, and that's with the $, which makes sense why you have $signs here in the environment. You can get the average. So if you want to do the average of caret size, you use the mean command. If you do have missing values and you're like, I don't want to create an entire data set, I don't really want to remove them, but I do want to see what my average would be without those missing values. This won't affect us because we have no missing values, but you could do this command that we were talking about earlier, which is the removing of non-available values. So I'm telling R, I want to see the mean of the price of diamonds and remove any non-available values. And by saying it's true, it means this command, removing them, true. Yes, do it. And it's going to be it would be the same as if we ran price without it, because we don't have missing values. Okay, really? Yeah. We got 5 minutes. We're going to hustle through creating visualizations. So I provided code for a histogram, a bar plot, and for, what's that last one called? Different type of plot. I forget what it's called. For you to kind of like mess with and create on your own. These visualizations are coming from the ggplot2 package, if that's of interest to anyone. This is the basic default code for creating visualizations. The very beginning of this workshop, I mentioned that we're going to go over that default code, but they're also going to get into customizing your visualizations so that they're actually useful and translatable to an audience. This is default code. So if I want to create a histogram, I'm telling R, go to the ggplot package. The data that I want to use for this visualization is from the diamonds data set. And then for this one, we can use a plus sign. It's add. You have to know which code you're running, if you can use the % in %, or if you have to use a plus sign. I'm telling R I want to use histogram. That's going to be the geom that I'm specifying is a histogram type of plot. And then this is where the code gets confusing. You don't have to know how to write this out. I don't think anyone does. Like, I get all my code from resources, from textbooks, from the internet. I load it in, and then I just kind of edit all of my scripts to fit to the data that I want. But what this is basically saying is for the data, I want the aesthetic to be that on the x-axis, you're seeing caret. Just from this little information, R knows to create a histogram using caret size down here at the bottom. What's great about R Studio is that your plots you can see on one screen. If you use the regular R app, these come up as pop-ups and they're really annoying. You can't see them all together. So histogram shows distributions. This distribution is kind of wonky. It's a little spiky. So if we wanted to change the distribution and how it looks, we can specify the bin width. So in this case, if we make the bin width just a bit larger, same code for everything else, we made the bins larger, so the distribution is just a little bit smoother. So it's however you want to look at your data. You can customize it that way. For bar charts, it's the same intro. Go to ggplot. I'm using this data, the diamonds data set. This time, the geom is going to be bar instead of histogram. And this time on the x-axis, I want to see cut. And so as we said before, cut is an ordinal variable, and you can see down here. Now we have a bar chart looking at the count of each diamond in all of these categories. So we're not going to do the frequency polygram, in those pretty cool data set. I'm going to leave you here with customization. So this is the Harry Potter data set that I was telling you guys all about earlier. So you don't have to do this on your own, but I'm going to read everything in just so you can get a sense of why customizations are so important. So this data set has all the characters from Harry Potter. And let's say you're like, all right, I'm really curious about how many characters actually fall into each of the Hogwarts houses. And you want to visualize it. You don't really care about looking at the values. I'm going to create a bar chart. And this time I'm telling R to create a value. If I got rid of this, it would still run and it would pop up, but I wouldn't be able to recreate it. And I like recreating things, so I want to give it a name. So I'm saying bar 1 is going to be a plot use the Harry Potter characters data set. On the x-axis, I want house. And I want it to be a bar chart, and I want the statistic to be a count of how many characters are there. So it says, great, did it, and now I want to view it.